Yes, yes.
Okay, great. Thank you. Okay, so thank you for coming today's demonstration on our new I suddenly a Raman spectrometer, and Eric will introduce the whole the machine and how to use it. Okay, so now it's your turn.
Sorry, we were having a little bit of, so there just a disclaimer before we get started. The screen is very small on the instrument. We were just working to get it hooked up to the computer. You can run it off the computer. It's much easier to see. But we were having a few issues with that, so we probably needed another 15, 20 minutes. So we'll get that going after this demonstration. But just for the purposes of what we're doing here, we'll show you how to work. We'll try to get close-ups of the screen so you can just kind of get an idea of what's happening. We'll run a sample, show you the basics of how it works and what we can do with it. And then I guess once you guys can get in the lab and play with it, you'll see a lot more of the capabilities, but we'll just do a general overview. And if you have any specific questions, we can try to address those as well. Show the screen or...
Okay, maybe this way, this way. Oh, what we did just now?
Yeah.
Can you move it?
Yeah, let's back it up a little bit here. Can you just see the screen?
Okay. Yeah,
That's not very useful, is it?
But at least if people see the control pad.
Yeah.
It cannot go too close.
Can we?
Yeah.
Can you guys see this at all? Not really.
I can't see the word that's in that teal square.
Okay, it just said ready. This is, so there's that's kind of the basic window where you can run it, and it'll say if you're comparing it to a known or unknown or to a known substance or doing a verification, it'll just give you a green like passed, failed, whatever you need to see. This is more of the advanced window, which is much more useful screen where everybody's going to usually be running things from. This will give you your spectrum. As you can kind of see the XY axis in the top square. Sorry for this. It's not the best visibly, but you have your intensity and counts on the Y-axis, your Raman shift on the X-axis. Really, the software, I think, is probably going to be something you'll have to look at when you get closer, but I will go through and show you some of the options. Hopefully, it's not a complete blur the whole time.
Can you try turning off some overhead lights in that room?
Okay. Ooh. No.
Will it autofocus is the question. No.
Okay. How about now? Is it a little better? Because the screen is really so tiny.
Yeah, it's a little better now.
Okay.
I don't know about everyone else in the call though.
I mean, I guess without moving it,
Yeah.
we can. So these, we have two different probes. So we're doing all measurements outside of the actual instrument. So we have two different wavelength lasers. We have a 785 and a 1064 nanometer. So you have methods set up based on which laser you'll be using. This one's 1064. The 785 is exactly the same thing. It's just, you know, they're labeled here. Sorry that it's upside down. The fiber's going the other way, so I can't do that. To use these, they do have a slide switch that when you're ready to run your sample, this has to be slid over. Where's my, just to give you an idea, you'll have your sample sitting. You want to move your sample close to it. You'll hold it there while it's acquiring, and then that'll be done. This is spring loaded, so it'll always go back to close off. You want to make sure when you're running this, there is an indicator light here that will be red when the laser is on. As with all lasers, you want to be very careful. Keep them away from your face. Don't point them at anybody else. The 785 nanometer laser is, you know, it does have the red color to it. So you kind of, if you see it, you'll know and you can look away quickly. The 1064 is invisible. It will cause damage to your eyes. We do have a pair of laser safety glasses here. You've never seen them before. That we recommend wearing whenever you're doing measurements, and also just for safety purposes, if there's other people in the room, make sure they're not directly in line with the laser. I think that kind of goes without saying, but just to, for safety precaution to mention. So I'm going to run a sample real quick, and we'll show you what the spectrum will look like. What's that?
Oh, you want to point?
Yeah, I'll point here, I think. So we'll go to settings. These are our normal settings. I'm sorry, it's hard to see. So up top, you'll have your laser wavelength. You can change your exposure time. You can change your power level depending on, what you're looking for, how fast you want to take it. Its default is about 600 milliseconds. Laser power default is about 300 milliwatt. Like I said, depending on what you're measuring, you can increase or decrease that exposure time, or you can, increase or decrease that power. I'm not sure off the top of my head what the max power is. This 300 may be max. I would have to double check. You can take multiple spectra. So this here says number of average spectra. So you can, run as many as you want and overlay them with each other. It averages them out and then gives you one spectra. You can do multiple scans. So say if you have a reaction that's taking place, you can set it up to run, maybe 10 scans with a, 1 minute delay between each one. So every minute it's going to take a scan and it's going to show you, so say like a degradation of a peak or appearance of a peak. So you could potentially see some intermediates or some, reactants going to products, for example. This is just minimum peak intensity. You can do baseline correction, or so we have subtract dark background, which is taken. Which is taken every time you run it. You can choose to do that or not. Since we're doing it outside of the instrument, there's going to be a lot more. The dark background is going to be shifted up a lot more. If you were to say do this in a box or with the lights off, you're going to get a much better baseline there. You can do baseline correction if you want to kind of clear up some of that noise. Again, it's up to you. I know a lot of users with Raman don't necessarily use peak area. Instead, it's peak intensity, those counts. So really the baseline is up to you. You can run a blank and then run your sample also and use that as your background. That would be subtract user background option here. It will ask you to run that when you're doing it. And yeah, that's pretty much it for this. So we do have a library on here, which I'll go through. So what we're going to do is load method. We have really two general purpose methods in here. This one says method general purpose. That's for the 785, and then method 1064. That'll auto load your laser, get everything ready to go. So we'll start with the 785. You just hit open. It gives you all the settings for it. Now you can open that method, change these, and if you hit save, it's kind of a save as, so you can build your own methods, name them whatever you want, and have it there, but you'll always have that general method as the one to go back to. Once you have that, we just hit set. Oh, we have to hold this button in for a second. That's arming the laser. So the laser doesn't automatically come on. That just means it's ready to be run. So you have this ready to go. And then what we'll do here is a single acquisition. I don't know if you want to kind of show this part of it.
I can.
So this is kind of the crude way to do it. You can set up with say a ring stand or some kind of holder for your sample or whatever. But this works fine for general purposes. So what you say is you'll do single acquisition. You want to hold this pretty steady and as close to, give it a little bit, maybe a few millimeters of space. If it's too close, you risk the laser going completely through the sample and you don't see it. And you get a lot more noise. And the same thing if it's too far away, you kind of want that focal point to hit right in the middle of the sample. So we hold it here. Let me put my glasses on. Make sure I'm being safe. Not sure.
Say that.
Okay, so we'll hold this here and then we'll hit Single acquisition. The laser is on. It's acquiring. Acquiring background. Hopefully you can see it okay. Okay. And that's our spectrum. So this is a polystyrene sample. I think I was moving a little bit as I was looking back and forth, so we do have a little bit of noise on it. But so what we can do, there is also a library. So this polystyrene is used as a daily verification standard. You run it, it verifies it, it'll say verification passed. So that is a known, and it is in the library. So once we run something, if we are looking for an unknown, we do have a built-in library. You can see the compounds. I'll let you look through that as you need to. So you can go to Analyze Spectrum, and you can, if it's something that you know what it is, you can put Verify Unknown Substance and add that to the library. Or you can do Identify Unknown Substance. So you want to check, we did the 785 laser. So we'll do Identify Unknown Substance. And it didn't come out very good. It's saying it's benzyl alcohol, which is not. All right, hold on. I'm sorry. Let's try and run again because that was not the best. Bear with me for a second. We're still working out some. I think I was a little off to the side last time. There, that looks better. Okay, so like I said, Analyze Spectrum, Identify Unknown Substance. I don't know why it's coming out as benzyl alcohol. Huh? Oh, you know why? I promised last time we did this, it was like 95% polystyrene. I don't know why it's... Anyway. Anyway, so when you run these, I'm not sure why this isn't lining up. You can tell there's some difference in these spectrum here. But what you're going to see is your spectrum is going to be in black, and then the library spectrum is going to be in red. Why is it? I'm not sure.
One more time. The acquisition. I can click the side.
Yeah, try one more time.
Okay, let's try one more time.
This worked perfectly when we did it 20 minutes ago.
Of
course. Turn off this library. It's still saying something's off. Let's try the other one. I'm gonna run this one. Okay, so this is the benzonitrile standard, which is used as a calibration standard. We're going to see if that gets it better. I don't know why the polystyrene is suddenly showing up as... so this is 95% match to benzonitrile. I have to look at that polystyrene. It was matching it like 95 to 97% earlier, and now it's calling it something different. Maybe there's something on my hands that I touched that, did it. So that's what you do. If you have an unknown, it's a pretty extensive library. As I know, you can't read these, but there are quite a lot of samples in here. So if you want to do a verify an unknown, or if you have something that you know is pure, you can run it and add it to this library. You can create your own specific library. I know there's a lot of different projects going on, so you can have your library with your name on it, your substances in it, and do it that way. You can also, so every spectrum, you save it, name it however you like. You can create your own folder, save it to your folder, export that as a CSV, and then you can do whatever you need to in Excel. And if you have any questions as I'm going, if I'm talking too fast, please just let me know. And the other thing to mention is if you want to do like a sort of your own calibration curve on this, right now with this, we just released a new generation of instrument that's got some more capabilities, but with this instrument at this time, you really need to prepare your own standards, you run them, you take the data off of here to Excel, and then build your own calibration curve, and then you'll have your equation that you'll need to use to kind of back calculate when you run unknown samples. So that's really the easiest way to do it as of right now, to kind of set those factors in Excel and run them that way. Is there anything else to go through? So really that's the main thing. If you're gonna open a new method, so if we wanted to say change the method, you just do, like I said, load method. If we were gonna change to 1064, open, set, it does kind of tells you that it's switching from laser to laser, kind of goes through that. Just, it's just a patience thing. They said mostly these indicator lights are going to be what you're going to look at. These buttons, you can use them obviously to look at the advanced settings, spectra, reset settings. You likely won't even use these, especially once we get it hooked up to the computer here. You'll be able to basically, you can run the instrument itself straight from the computer with a nice big screen and don't really need to deal with the screen at all, other than the power on and the arming the laser you'll still need to use from here. Let's see if it, no. So we'll have that set up before I leave today. But that's just the basic kind of run through of the instrument. It is pretty simple. It's pretty intuitive. Just remember to save your spectrum. This does have a thumb drive that you can plug right into the instrument, transfer your samples to it, take them back to your computer, and do as you need, or just put them. You can put them directly on a network if you need to. Go from there. I would say the main thing to keep in mind when running this is, since it is an external probe, obviously it's fiber optics, so you want to make sure that you're not bending and pinching the wires. They will, they will break and it won't work anymore. And then just kind of, they said we had mentioned that if you want to set this up so you have, maybe a ring stand holding this, so all you need to do would be to move the button when you're acquiring, or potentially, some sort of sample holder so you can have that distance between the sample kind of set. It is going to be different for every sample, but most of these smaller samples you're going to want to get, a few millimeters away. And then the other option would be to have sort of a box around it for, for that dark background. So you're going to have a much cleaner spectrum. You can see when you do an overlay from the library versus a sample that we did here on the benchtop, it's not going to be 100% because you'll see that background when it was done in the instrument for the library. It was completely dark, so it sits nice and flat right on the baseline. When you have it out in the light, there's going to be a little bit of an elevation, so that alone is going to hurt some of that best fit. But if you do look at the intensities of the peaks, you can see that they match up very well at the max, but you're just going to lose that on the baseline. So it's kind of up to you how to optimize this and what you want to do with it. But we do offer application support. So if you're having an issue with a sample, we have some experts that are very good at Raman, know much more than I do, and we offer that all the time. So if you ever have questions, anybody, it doesn't matter who's using it. If you have questions, you can reach out to me and we can get you those answers, help you set up. You know, if you have really difficult samples that you're having a hard time with, you can send us some, and we can try to optimize a method as well. Different things we can work with to get your application ready to go.
Yeah, thank you. Any questions?
Yes, I have a question. I wasn't here in the first few minutes when you started. So can we measure the sample inside the instrument? Because I only seen you using the fiber optics externally.
So there is a stage that you can buy, if you want to show here. There is a stage that you can buy that sits inside the instrument, so that you can. It's got a small sample holder for different sizes, and you can put it directly into it and use it that way. This instrument was not purchased with that. So for this instrument that you have here, we only have the fiber optic probes. If that is something that would be needed in the future, we can discuss that, and potentially that would be an upgrade. But that right now, all we have is the probes that were purchased with this system.
Good, thank you.
The next question is, what's the resolution for both wavelength?
The max resolution. I'll have to look that up. I will get back to you with the max resolution question. I need to look for that. But I will. Do you know who said it? I can.
Yeah.
Just make a note, and we can. I'll get you that answer. I'll have to look for it. I don't have it off the top of my head.
Okay.
Why waste our time doing that? But really, I think it's very easy to use. Like I said, you know, just keep an eye on the safety things. That's the main part. It is a safe instrument, but you know, I'm sure everyone's very careful when working with lasers, and you're familiar with that. But really, it's something to just, you know, kind of play around with and get an idea of how it works. The software is pretty simple. Building the libraries, running the samples, saving the spectrum, it's all very easy to do. It's just going to be a matter of, you know, working with your samples and how you want to use it. You know, there's not really one specific application for these. It's kind of what everybody wants to do. And, you know, Raman is pretty new to our company. We're still learning where a lot of people use it. So if you do have some interesting applications, you know, we'd be happy to discuss them with you. And just if you have something really cool that you are doing with it, we would also like to hear that kind of as a success story. We have some application reports that we're always working on, and we will work with third party, you know, our customers. If you have a cool application that maybe hasn't been done before, and you know, if you've already published or whatever you want to do, and you want to just kind of have a, hey, we did this, and we'll work with you, and you know, have some of that. If we can share that as well based on, you know, your successes with our instrument, we'd be happy to do that too.
Okay, thank you. And I also want to maybe show all the users about the software part you mentioned.
Mm-hmm.
So Eric and I will just now try to install this software on this computer, but got some problem. So let me show. Yeah, but eventually we will. Yeah, eventually we will have this software ready on the same computer connected with the reometer. So it will be just a small thing. Now we just have a little problem.
Yeah. Sorry for the resolution on the screen. I said when you're standing over top of it, it's not even the easiest thing. So this was the last thing we were working on when the time got here. But we'll get it hooked up on this nice big monitor. You can use a mouse. You don't have to use the stylus. Run everything straight from this computer. Control the instrument, and it should be much easier. It's not impossible to use here though. So rheometer integration. So it is possible to integrate these our Raman with rheometer. That's kind of a more of the rheometer team question. We have some experts. I would have to refer you back to that because there's some different things that need to be purchased in order to hook these up to each other, and that's more of how it hooks to the rheometer. Oh, you have those? Okay. I didn't know that. We'll have to talk about that because that's not something that was relayed to me and hooking those up. And we're likely going to have to get one of our, basically probably our rheometer expert out rather than just a simple install. That's not something that that was relayed to me with setting this Raman up. So we'll have to talk about that. I'm sorry. Yeah, we'll need to look into that more because nobody mentioned that to me. Typically, it's the rheology team that we work with to do those.
We have him here. Let's do.
So our product expert would likely have to come out and do that rather than our normal install. So we'll relay that message as well.
Okay. Yeah. Okay. So that's almost everything. Any more questions? So.
And if questions come up, they can direct them to you and just let me know, or you can direct people to me. I'll leave my card with it if somebody wants to give me a call or send me an email. I'm happy to help or get you to the where we need to go.
Okay. Yeah, I think that's almost everything we want to cover today, right? For this, yeah.
And we'll get that resolution.
Okay, so any other question? If not, then that's it for today, and we will figure out the software on computer and also the integration part.
To the rheometer.
Yeah. Yeah. Thank you.
Thanks, everyone. Have a good day.
Thank you.
Figure out this computer.